Alrighty, nerds. I already told you before I started the recording, but this is the beginning of Unit 2.2. It is a 2-day lesson. The last 2 days, our lesson was called Change in Arithmetic and Geometric Progressions, or Sequences. And during those lessons, we talked about how arithmetic sequences are essentially linear, and geometric sequences are essentially exponential. Well, check out the title on today's lesson. Change in linear and exponential functions. And today's material is going to darn near seem useless and redundant because it's just the same material, only now we're going to call them functions instead of just sequences. Okay? Okay. We've already talked about the relationship between linear functions and arithmetic sequences. We said that you could actually write an arithmetic sequence in a format that looked like y equals mx plus b, where m was the common difference, and this b, your y-intercept, was actually, we were calling it a sub 0, which we said the best definition for a sub 0 is the term before your first term, right? A sub 0. Well, not only do they look like linear equations, you can actually write a linear equation in function notation for arithmetic sequences today and geometric sequences tomorrow. And we'll call them linear and exponential functions because we'll use the letter F. So here we have the graph of a arithmetic sequence. I'm hoping you can see that you could connect all of those dots with a straight line if things existed between the first term and the second term, or between the second term and the third term, so on and so forth. I would also like you to see that these dots don't go all the way to the y-axis, because these dots represent A1, A2, A3, A4, and A5, and A6. There is no such thing as A0. Now, could we figure out what A0 equals? Of course we can, and we will in a moment. First, let's fill out our table with the known A sub n values. So this is not xy, it is n comma an. 1 comma negative 5, got it. 2 comma negative 3, 3 comma negative 1, 4 comma 1, 5 comma 3, and 6 comma 5. There it is. It says find the difference and write an explicit rule. I'm hoping you can easily see what the difference is when you go from A1 to A2. What am I doing to my A subs? Adding 2. That means our common difference is 2. And let's write our explicit rule using this format. The reason why I chose that format is because I can see A1 and we've already determined what D equals. If we wanted to write this as a linear equation in terms of n, then all we have to do is distribute our 2 and combine like terms. Or realize that D represents the slope of this thing, and the B value, your y-intercept, would have been the term that came before the first term. So what would have come before the first term right here? What would have A sub 0 been? Negative 7. You see, if you subtract 2, you get to here, you'll get negative 7. That is not on this picture, and I'm not going to add it to the picture, because A sub 0 is never a part of the sequence. But if I want to write this thing in its what looks like slope-intercept form, then I can say f of n instead of saying A sub n. I can say a function in terms of n for this is the common difference times n plus A sub 0. And there you have it. That's it. And I would have gotten that if I had just distributed the 2 and combined like terms. But I wanted to make a point of the fact that even though I could find this value, I still can't put it on this table. And I'm not allowed to connect these dots. And what do we know about n? What kind of values are we allowed to use for n? What would the domain of this function be? Positive, what'd you say? Now she's checking out. Positive what? Positive whole numbers. Also known as positive integers. Yes? How did I find what out? Positive integers? That's a rule from the last lesson. Because for a sequence, you can only have the first thing, the second thing, the third thing, the fourth thing. There's no such thing as the 1.2th thing. There's no such thing as the -2th thing, right? So we could do like this. We could say that n, hey guys, we could say that n is an element of, draw what looks like a 7, and then an upside down 7. And then you put a little plus sign on it.
Am I using that too?
I wrote it in the notes. You might want to be able to read it just in case it shows up on a test. No, that's double struck Z. This little symbol means element of. This says n is a positive integer. That's what this says. I don't know. It's just the symbols that mathematicians use. Integers. Element of. N is an element of the positive integers. It means n is a positive integer. It's any positive integer you want it to be. Okay? Okay. What are we lost by? Okay, great. 0 is not an integer. Well, okay, no, stop. 0 is an integer, but it is not a positive integer. Integers are non-decimal numbers. So all positive and negative whole numbers, those are integers. But 0 is not a positive integer. So positive integers begin at the number 1 and count up. They're also known as the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's another way of saying it. The counting numbers. What? Oh, okay. Next. Given the sequence, arithmetic sequence, where a sub 1 is 17 and a sub 8 is -39, we're going to state the domain and the range. We can do the domain now. That's easy. But for this domain, can I use interval notation and say from 1 to 8?
No.
Why not? Why can I not use interval notation, say from 1 to 8?
6.35 is between 1 and 8.
Oh, that's a good, he specifically said because 6.35 is between 1 and 8. Yeah. So the problem with interval notation here is that interval notation allows everything that falls between 1 and 8. So if you want to say only the numbers 1 through 8, you can either use something called set builder notation, which is not something you have to know how to do, and uses even more fancy symbols, or we could just list the numbers as a set. Sets go inside braces. If you don't know how to draw braces, here's your quick brace tutorial. Draw a tall, skinny S, and without picking up your pencil, draw the same thing, only backwards. So our domain is the numbers 1, 2, 3, 4, 5, 6, 7, and 8, and comes to an end. There it is. That's the domain.
What's the fancy symbol?
This thing?
No, the one that you said you have to use more.
You don't want to know set builder notation. It's a waste of time. We need to finish the lesson. It's a waste of time unless you're going to be a math professor. Okay? All right. The range is all of the a sub n's. But I don't know the other a sub n's. I need to find them. All we know is that this thing is arithmetic. So since it's arithmetic, what are we guaranteed to have? It's linear, which, what's that? A common difference, absolutely. We need to find this common difference. And the way we do that is by saying, oh, if I go from the first term to the 8th term, How many times have I added the common difference? 7 times. So we could say that a sub 8 is a sub 1 plus 7 differences. And this is how we can solve for the common difference. This isn't new. This is what we did 2 days ago. So negative 39 equals 17 plus 7d. Subtract 17 from both sides and you get negative 56 equals 7 differences. Dividing by 7 tells us that our difference is negative 8.
Could you just add them and then subtract or divide by 7?
That's exactly what I did. I added them and divided by 7. Well, no, not added them. I subtracted and divided by 7.
Yeah.
Subtracting them finds the difference between them and then dividing by 7. It should also sound like slope, shouldn't it?
Yeah.
y2 minus y1 over x2 minus x1.
So it's a line?
Well, yeah, it's linear because it's arithmetic. So this is essentially you using, that's solving for slope. So all we have to do is subtract 8 to get our range. So I'll use orange again. 17 minus 8 is 9, then 1, then negative 8, then negative, I can't, hold on. I said hold on. 1 minus 8 is negative 7. My apologies. Goodness, you crucify somebody for negative 15, negative 23, negative 31. There it is. Don't draw on his hand. Our range then are the a sub n's, and they'll be written as a set as well. And I don't think order matters in a set. It's not an ordered set, it's just a set. So it's not like interval notation where you have to go from small to big. So what have we done different so far today? We've used f of n instead of a sub n, and we've defined the n's as our domain and the a n's as our range. That's all we've done new. And I'm pretty sure that's all we're going to do new. Now we're just going to do that stuff over and over and over again. Write a linear function whose domain is all real numbers. Oh, a function whose domain is all real numbers, but those will contain the domain of this sequence. Okay, if I say all real numbers, what variable are you typically using for your functions? X. Yeah. So you can either write this as an f of x, because it specifically said the domain, since all real numbers, would contain this, or we could use f of n. And we just know that because it's a sequence, this must be a truth. So I think that this question's, and I'm going to say this more than once today, the directions are a little bit open to interpretation. I don't think it's saying write a function whose domain is all real numbers. I think it's saying write a function whose domain is all of the numbers that would have included this, but don't stop. So I'm just going to use a little bit of interpretation here and just say f of n. We might as well write it as a linear equation. We know our slope acts as our common difference. Wouldn't it be great to know what a sub 0 is? The y-intercept, so to speak. So come up to the table, put a 0 right there, and ask yourself what term would have come before 17? 25 it is. Because that would have been 17 plus 8. There. That's it. It should show your steps. I mean, the only steps that we could have shown was if we had chosen to write it like this and then distribute the common difference and combine like terms. As far as I'm concerned, this was our showing our steps. You guys cool with that idea? You're not cool with that? So how did we get from 17 to 9? Okay, so if you go the opposite direction, what do you think you should do? Add 8. There you go. That's how we got it. It's the same thing we did here. When we went from -5 to -3, we said that's +2, so to go backwards is -2. So the explicit formula denotes the nth term of the sequence where n tells the term's location. We've already known that. It defines the sequence as a formula in terms of n, so this would be the a sub n formula. And that could either be written as a sub n like you're used to, or we could use function notation f of n. There's literally no difference between those two setups. Here's another graph. We're going to fill this table out. You can see that term 1 was 32. It's right there. Term 2 is 20. Actually, I'm going to read them off right here. Term 2 is 27. Term 3 is 22. Then 17. Then 12. Then 7. ... Because, well, you know, the sequence doesn't have to come to an end. So if this is a sub 1, that makes this one a sub 2.
Are you saying a sub?
A sub 1. Sub. Like subscript or superscript, a sub 1. This is a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and they never have to come to an end. So guess what's going to be over here? F of. Yeah. Yep. There it is. Subscript notation. I'm going to write this one in the general term that we're used to seeing, probably the one you were introduced to in Algebra 2. A sub n equals a sub 1 plus n minus 1 times d. I could see what a sub 1 is. Oh, I need to know what the common difference is. Well, how am I getting from one term to the next? Subtracting 5. Cool. We know what the common difference is. Our subscript notation filled out like this using a subs is a sub n equals a sub 1, which is 32, plus n minus 1 times the common difference of -5. And since the order of multiplication doesn't matter, you could also put this -5 in front of these parentheses and write it as 32 minus 5 times n minus 1. Because the reason why I don't like to do it is because I like to say to get from one term to the next is this number of differences. So it would be 5 differences or 5d. It just makes more sense to put the variable at the end of the expression. I also like to write it like this in case the difference is negative, because I'm much less likely to forget that I'm distributing a negative number. Because if it said 32 minus 5 times n minus 1, a lot of people that aren't super proficient in algebra will distribute a 5 instead of a -5. But if you do it like this, it's kind of hard to miss that negative sign. I would say that's probably the only reasons why. Because it actually doesn't matter. It means the same thing. In fact, look at the next example. So it really doesn't matter. Function notation. That'll be the purple one. F of n equals, our common difference acts as our slope, -5n. Sure would be nice if I knew what a sub 0 would have been. $37, there it is. It would have been 37. Because if we're subtracting 5 as we go that way, we're adding 5 as we go that way. 32 plus 5 gets me to 37. And there is absolutely no difference between these two. It's just the way they look. They mean exactly the same thing. And we could have gotten this if we just distributed -5 and combined like terms. Just another way of getting it. But we'll never plot a sub 0 because it's not part of the sequence. Given the explicit formula right here, we can see it's arithmetic because this would be our common difference. Write the first 10 terms of the sequence. And you could write these as a set, or you could write them as A1 equals, A2 equals, completely up to you. I chose set notation on my notes just because, why not? But what we do need to know is what is A1 and what is D. What is A sub 1? What is it? A sub 1 is going to be what we get when we plug in 1. Because this does not say n minus 1 like it's supposed to. This is not A sub 1. So we find A sub 1 by substituting in the value n equals 1. So that is 9 minus 3 times negative 3. That is 9 plus 9, 18. But what is the common difference? Common difference is negative 3. I'm going to use, like I said, set notation. Our first term then is 18, and we are subtracting 3 every term after that. So we go down to 15 for term 2, 12 for term 3, 9 for term 4, 6 for term 5, 3 for term 6, 0 for term 7, negative 3 for term 8, negative 6 for term 9, and negative 9 for term 10. And let me tell you how hard that was to say without goofing up. That was rough. Because I was having to do the subtraction in my head. So I was subtracting 3. I was saying a term number, and I was saying then a different term value. No, I didn't have it memorized. I actually didn't do it last period. I'm actually very happy with myself that I was able to pull that off. Fun. Okay, anyway. It says find the 200th term. Ugh. That means I have to substitute 200 in for n. Yeah, he wants to know what's 199. No, 196. See, because it's not written in the standard A sub format that we're used to, is it? 9 minus 3 times 200 minus 4. And I don't know about you guys, but I don't instantly know what 3 times 196 is. So I would grab my calculator. And that calculator would give me the number negative 579. You know what would have been easier? If we had just written slope-intercept form, it would have been a lot easier. If this is A1, what would A0 have been? 21. Oh. The function notation version of it then in slope-intercept form is negative 3n plus 21. And this would have been much easier to work with. Because what's negative 3 times 200? Negative 600. But then negative 600 plus 21 would have gotten us there. So really fast. This one's actually easier to do than that one. What's that? You should. I was doing it in the order that it was asked. Why? Green Fn? I don't get it. From what?
It was popular on TikTok for a while.
Why?
It was the popular thing. People would just say that. Yeah.
Green Fn?
Yeah.
The only thing I know of that's FN is a gun brand. So I thought it was a TikTok, not a TikTok, like a, what's that game called? Fortnite. I don't know. I don't know. I'm good. Next. Using explicit formulas. Okay, so word problems. Oh, okay, and I do want to warn you a little bit. These are open to interpretation a little, determining if you're starting with A0 or A1. Don't worry about that. It'll be much more clear when you have to do actual test questions and things like that, okay? Elizabeth waters her vegetable garden using water she collects in a 55-gallon rain barrel. On May 3rd, the barrel was full of water. On May 8th, the barrel contained 47 gallons of water. So she's clearly watered these plants. The way that I interpret it, the way that I think it's easiest to do this, is to say that N is the number of waterings that have occurred. And if we do that, if N is the number of waterings that have occurred, then does May 3rd, when the barrel was full, represent A sub 1 or A sub 0? So if the barrel is full, how many times have we watered our plants? None. So if you say that N represents the number of waterings, then May 3rd represents A sub 0. It's just how you define it. Again, open to interpretation a little bit. So I'm letting you know how I'm going to work through it. That doesn't mean it's the only way to do it. It just means that it's the way that I want to do it. And it actually makes the numbers easier to work with if you do it that way. So I'm going to say N equals the number of waterings. And we do one watering per day, so it's actually a way of saying how many days have elapsed. Okay. So then, what is May 8th? Is it A sub 7? It's 7 days after the 3rd? In case you're not sure, let's figure it out. May 4th, 5th, 6th, 7th, 8th. Looks like 5 to me. A sub 5. Cooper?
A0, May 3rd? Or May 1st?
A sub 0 is May 3rd because no waterings have occurred yet, and that's why the barrel is full. So that makes May 8th A sub 5. It says to write the first 6 terms. It's kind of hard to do that if you don't know how much water you're losing each day. So once again, we're going to have to start with finding the common difference. This is 5 waterings after this. Yes? So all we have to do is figure out how much water we've lost and divide by 5. I will write it out as formula though. A sub 5 is A sub 0 plus 5 common differences. 47 is where we are. We started with 55, and after 5 waterings, 5 common differences, or this is how much we have after 5 common differences. There we go. So subtract 55. We get negative 8 equals 5d, and dividing both sides by 5 shows us that our common difference is negative, and we might as well use a decimal, 1.6 gallons of water per day. My math is going to have to get skinny. So is 55 going in my list of first 6 terms? No, it is not, because it's representing A sub 0. The first term then is 55 minus 1.6, which is going to be 53.4. Then 51.8, we're just subtracting 1.6 each time. 50.2, I'm not going to lie, I'm looking on another page to see what these numbers are. 48.6, 47, finally a whole number, and get skinny math, suck it in. 47 minus 1.6 is 45.4. Okay, I got it on there. Barely, but there it is. You can't see it? Oh, you weren't telling me, you were telling him. Okay, no big deal. Write an explicit rule using both subscript notation and function notation. All right, well, let's write our a sub 1 style formula. A sub n is a sub 1 plus n minus 1 times the common difference of negative 1.6. 53.4, yeah, a sub 1. Or the easy one. Common difference acting as your slope, negative 1.6 n plus the term you have before the first watering, which is 55, because the barrel's full at 55. Now part C is kind of fun for me. It says explain when the rain barrel will be empty. Assume there is no more rain, and I have no idea what this... I don't know why that next 10 days stuff is there. It means nothing. Just assume there's no more rain. Explain when the barrel will be empty. So what does empty do for us? What does that tell us? 0. Yep, it tells us Fn is 0. And we've already said Fn. I want to use this formula because it's easier. And again, we're talking water, so I'll write it in blue. 0 equals negative 1.6 n plus 55. I'm going to add 1.6 to both sides and then divide. That tells me that the number of waterings is 34.375. So how many times do I dip into this rain barrel in order to empty it? 35 times. Because after the 34th dip, there's still a little bit of water. Not much, but there's still some. So it's going to take 35 days. Now the question does say when, and it started with dates, right? So this is 35 days after May 3rd. Well, there's 31 days in May, which is 28 days away from the 3rd, plus another 7. So that's going to be June 7th. We'll be out of water if it doesn't rain again. Mr. M, do I need to know the days of the months to be successful on the test? No. No. You don't know how many days in a month? Ask. I'll tell you if there's a test question like that. There probably won't be. Don't freak out. Okay. Can we move on to the last example for the day? No. You said no? Oh, now you're kidding. Oh, okay. Alan is assigned a book to read for his biology class. Counting today, Monday, as the first day, he finds that he must read through page 385 by day 12 and through page 665 by day 20. It says, write a rule for the nth term of the arithmetic sequence that represents the number of pages that he will have read after n days. Now, again, this question's open to interpretation. Last period, I treated it like let's say it's a homework assignment, right? And if I tell you that by the 12th day, I need you to have already read 385 pages, how many days of reading did you actually get? 11 days of reading. So if I say, hey, on the 12th day by the 12th day of class, I need you to have read 385 pages, that really means you only had 11 nights to read, right? But it's not 12 days if I needed you to have showed up on day 12 having already read it. So again, this question is open to interpretation. Do we want to include day 12 for these 385 pages or not? So you want to say by day 12. So you're saying this is 11 days worth of reading. That actually makes the question a little bit boring. And here's why. 385 is divisible by 11. Makes it kind of boring. And 665 is not divisible by 11. 665? No, it's not divisible by 12. Okay, let's write a rule. Let's just write a rule, okay? And what we know is, and notice this isn't the a sub 1 version of the formula. It's the re-indexed version of the formula, where this could be anything I want it to be. So if we're going to say that 385 pages is after 11 days of reading, what color feels like book pages? Purple feels like book pages. Then what is day 20? It's 19. All right. We can fill this thing out with either of these. It doesn't matter, but we should probably go with the smaller one. We don't know a sub 1, but we do know a sub 11. 380, nope. I'll be okay. A sub n is, we start with 385 pages, and we will read an unknown number of pages per day right now. But because I used a sub 11 here instead of a sub 1, I have to write 11 here. That's how the reindexing works. Whatever this number is belongs there, as long as you're using that value there. Because that's a sub k. Or it says, well, what is the common difference? Well, how many days have gone by from A11 to A19? 8 days. So I can say that, and we'll go back to purple because there it is. I could say that A sub 19 is A11 plus 8. Oh, D for days. How about that? Plus 8 days. And fill out what we know. 665 equals 385 plus 8D. You subtract 385 from both sides, and we'll get that 8D is 280, I believe. Yes, 280. And if you do the division, you find out that the common difference, which is the pages per day that need to be read, is 35. Cool. You know what else you could have just done? You could have done 385 divided by 11. You would have gotten 35. But that kind of trick would not always work. Because what if we'd said this was a sub 12? Okay? It would have goofed this up a little bit. It really would have. Because then this would have been a sub 20, and we would have had this 280 being divided by 8 still. It still would have been 35. But if we had to read 35 pages per day, and this is in 12 days, it almost makes it so that we could read a negative number of pages on day 1. Essentially, we could slack off day 1. So the question is, like I said, open to interpretation, and that does make it a little bit frustrating. Just do whatever is easiest when you're doing the homework. Great. So what does it mean in terms of Alan's assignment? He must read 35 pages per day. Well, based on that formula, how many pages does Alan need to read today? 35. 35. because he needs to read 35 every day. I don't really understand that question. Seems redundant. Using your function rule, which is this one now, so we could write it as a sub n equals 385 plus n minus 11 times 35. How many pages will Alan have read by Friday's class? If Monday is day 1, but is Friday a sub 5? If we defined this one as a sub 11, then Friday is not a sub 5. It's a sub 4 because you only had Monday, Tuesday, Wednesday, and Thursday night to have read the pages. You see, so it really is open to interpretation. If I say by class time Friday, if I announce this on a Monday, by class time Friday, you're going to turn blank in. You know that means you had 4 nights to work on it. So I would argue that Friday is a sub 4. So you grab handy dandy calculator, and you're going to find out that it gets you 140 pages. You know what else you could have done? I only did that way because it said using your function rule. You could have just done 35 times 4, which is the same answer. Yep. All right, nerds. Thank you so much.